We're now going to discuss linear inequalities in two variables. And the biggest difference between inequalities in two variables and equations in two variables is that we need more than the line to express our answer. We also need some shading. And so what we're going to do is we're going to follow the same basic idea as graphing linear equations, but we're going to make some differences. So the first difference is that our line is either going to be dashed or solid. If the original equation has a greater than or a less than, it's dashed. If it has a greater than or equal or a less than or equal, it's solid. And so it's real easy to remember. If it's got a solid line underneath it, then it's solid. If it doesn't, then it's dashed. So to go along with this, we also have to shade. So the line is one difference, and the shading is the other. And what we want to do is we want to shade wherever the point makes the inequality true. So what we're going to do is we're going to start with an example and show this by example. But remember the difference between the line and the shading being the big differences. So suppose we have minus 2x plus 5y is less than 10. Now I'm going to choose to graph this by intercepts because I see that the minus 2 and the 5 both evenly divide into 10. So we'll start by saying minus 2x plus 5 times 0. And I'm going to change it to an equals just for a moment because the line itself goes where the equal sign is. That's how we know how to graph it. And so we get minus 2x equals 10. So when we divide by negative 2, x is negative 5. So I have a point at negative 5, 0. My next point comes from plugging in 0 for x. So we get 5y equals 10. We divide both sides by 5. And we get y equals 2. This then gives us a second point at 0, 2. Okay, so now we need to graph these. So we'll draw our rectangular coordinate plane. We'll put a point at minus 5, 0, and at 0, 2. So these are the 2 points that we came up with. Now, because the original is a less than, a strictly less than, this means we have a dashed line. So we're just going to draw a dashed line through these points. And then we need to figure out, do we shade on the left or the right? So to figure out shading, we plug a point in. So let's plug in 0, 0 into the original, always into the original. Minus 2 times 0 plus 5 times 0 equals, or sorry, is less than 10. So minus 2 times 0 and 5 times 0 is 0. 0 is less than 10. This is true. So I'm going to take my point. I tested 0, 0 and it was true, so I need to shade 0, 0. And since I'm already on this side, we're just going to shade the same side as the point we tested because it worked. And this gives us our graph. Now, let's look at a different equation. What about y is greater than or equal to minus 3/2 x? So we're going to start by graphing this one using slope-intercept. Because it's in slope-intercept form, y equals mx plus b. My m is minus 3/2 and my b is 0 because there's a hidden plus 0 hiding here. So we go into graph and we start right at 0, 0. And then we go down 3 and over 2 to get 1 point. And if we go backwards, up 3 and to the left 2 to get another point. Now, because it's greater than or equal, we're going to draw a solid line through these points. And when we go to test our point, notice that we can't test 0, 0. So let's test the point 0, 1, which is right here. So this is the point I'm testing. So I plug 1 in, and I want to know, is 1 greater than or equal to minus 3/2 times 0? When we plug this in, 1 is greater than or equal to 0, which is true. So I shade that same side that has him, which is everything up here. And again, we now have our graph of our linear inequality.